Okay, today we're going to talk about trig ratios. It's going to be the beginning of this, so we got to start with the basics. So trigonometric ratios are ratios that involve two sides of a right triangle. So we won't be able to use the Pythagorean theorem all the time because sometimes they're only going to give us one side or maybe one angle. So we have to use trig ratios to solve for the rest of it. And there's three of them. There's sine, there's cosine, and there's tangent. And there is a specific way we find these three trig ratios. So your new favorite word should be SOHCAHTOA. And I write it a little bit differently than some teachers do. But SOHCAHTOA, okay? And if you're looking at your calculator, you should see the sine, cosine, and tangent keys right there. So make sure you do know where those are in your calculator because we're going to be using those a lot. But for now, let's just talk about the actual ratios. So this SOHCAHTOA will help you remember what goes over what. So sine is opposite over hypotenuse. By the way, we call this sine, not sin. And this is opposite divided by the hypotenuse. Okay? And cosine will shorten to COS. That's going to be adjacent over hypotenuse. So I'm going to abbreviate it, adjacent over hypotenuse, okay? And then we have tangent, which we abbreviate TAN, and that's opposite over adjacent. So SOHCAHTOA will help you remember those ratios. Opposite over adjacent. So let's look at this triangle right here. You see it's a right triangle, and the first thing you always want to do is circle your reference angle. I will tell you right now, when students don't do this, they're more likely to make a mistake. So we circle the reference angle. What's straight across is your opposite. I always label that first. The next thing I always label is my hypotenuse, which is straight across from the 90. And then whatever I have left over, I label as my adjacent, because that's the hardest one for me to explain to students. So let me run through that again. I always label my opposite, which is straight across from whatever angle you circled. Then I label my hypotenuse, which is across from the 90. And then whatever I have left over, I label as my adjacent. Okay, so we're going to use that down here. Now I'm actually going to skip number 1 because number 1 I'm going to have you guys do. So let me circle this. You do that on your own, but don't try it yet because I want to show you number 2 first. So looking at number 2, the first thing you're going to need is you're going to need to know all three sides. And we don't know side EB here. So because we don't know it, we're going to have to use the Pythagorean theorem to find it. So if we use the Pythagorean theorem, 20 technically would be our A squared. X would be our B squared, and 29 would be our C squared. And if we square 20, we get 400. So 400 plus X squared. And if we square 29, we end up getting 841. Then if we subtract 400 from both sides, we get 441 on the right-hand side. So X squared equals 441. And to undo a square, we would take the square root. So X would equal the square root of 441. And then the square root of 441 on the calculator ends up being 29. Oops, sorry, 21. Let's change that, 21. Okay, so X is actually 21 in this problem. So let's look at number. What you'll notice here first is that we have to do angle W. So remember what I said, you always want to circle the angle that you're working with, and then you want to label. First, label what's straight across from it, which is going to be our 21. So this is our opposite. Then label what's across from your 90. And across from our 90 here is a 29. So that's our hypotenuse. So that must mean our leftover right here is our adjacent, which is 20. So to find the sign of W, remember SOHCAHTOA. This would be opposite over hypotenuse. And looking here, we know that's 21 over 29. And what they're wanting you to do is write the fraction, and then they also want to give the decimal here. So if we do 21 divided by 29, and we're going to go 4 places out. So 0.72413. This 3 will not change this one. So 0.7241 is what we're going to get here. 0.7241. Okay, so for cosine, we said that was adjacent over hypotenuse. So looking at our triangle here, our adjacent is 20 and our hypotenuse is 29. So we have 20 over 29. Now when we do that on the calculator, 20 divided by 29, we look and see how to round this one. So 0.68965. This 5 will bump that to a 7. So 0.6897. 0.6897. So just make sure you're rounding correctly. And tangent would be opposite over adjacent. So looking at our triangle here, our opposite is 21 and our adjacent is 20. So 21 divided by 20. And when we go to the calculator here, 21 divided by 20 ends up being 1.05. So 1.05 goes here. Now we're not done, because now we want to find these trigonometric ratios of angle B. Do not use this exact same thing, because you want to relabel. So here's what I suggest. You draw your triangle, and now you're working with angle B. Okay, so circle angle B. And then let's go ahead and put our numbers on here. So I'm taking these straight from the triangle. However, what is your opposite angle now? 20. Look over here. Your opposite angle here was 21. But now that you're using angle B, you relabel. So this is your opposite. Across from your 90 is your hypotenuse. And then your left over here is your adjacent. So be very careful. You want to relabel. So we know that sine is opposite over hypotenuse. So looking at our triangle down here, our opposite is 20 and our hypotenuse is 29. So this is 20 over 29, and we already found that that was 0.6897. Then we want to do cosine, and cosine is adjacent over hypotenuse. So our adjacent here would be 21, and our hypotenuse is 29. So 21 divided by 29, and we've already found that that's 0.7241. And last we have tangent, which is opposite over adjacent. So opposite over adjacent, and our triangle here would be 20 over 21. So 20 over 21. Now I haven't calculated that yet, so let's do 20 divided by 21 on the calculator. And when we do that, 0.95238. This 8 will bump this 3 to a 4. So 0.9524 is going to be your answer. 0.9524. So just make sure that you label your triangle, and you always want to circle that the reference angle you're coming from. Now, this means that you are able to do number 1. So make sure you have number 1 done and have it ready for class whenever you come back in. So make sure you go back and you do number 1. You can pause it now and do it, or you can wait until the end of the video. It's totally up to you. But I'm going to keep going. So on this next part here, it says make sure your mode is set to degree. So in this calculator here, I have a button that says mode. And if you notice on third down the list, it says radian and degree. And mine is already set to degree. You have to make sure that everything is set to degree when we start doing these problems. Otherwise, you're going to get the incorrect answer. So if they tell you to just take the sine of 15, you're literally going to type that into your calculator. So sine of 15. And if you want to close a parenthesis, you can, but you don't have to. And it says round to the nearest 10,000th, which is 4 decimal places out. So 0.25881. This 1 will not affect this 8. So 0.2588 is going to be your answer. Just like that. Then we do cosine of 70. So we're going to do the same thing. We're going to hit cosine and then hit 70. Technically, we're finding the ratio of a side of a triangle. You don't know that yet, but that's technically what we're doing. So when we look at this, we have 0.34202. This 2 will not change this 0 to anything. So it's just 0.3420. 0.3420. And what I want you to do is try C on your own. Okay, so go ahead and take the tangent of 40 in your calculator and tell me what that is to the nearest 10,000th, which is 4 decimal places out. All right, let's keep going. You can do that now or you can do that later. It's totally up to you. Remember, you can always pause this video and rewatch it. Do whatever you need to do to understand. All right, so on the next part, it says if we're given the decimal approximation already and we want to find the angle, then we have to go in reverse, which means we take the inverse. Kind of rhymes there, right? So you're going to use the inverse here. Now, if you look at my calculator, you'll see that right above the white buttons, it'll have the inverse. See that sine to the -1, cosine to the -1, tangent to the -1? Those aren't actually exponents. Those are notation, and they're telling us as the inverse of sine, cosine, and tangent. So, notice here, and this is how I always remembered it in school. I can't type sine x into my calculator, right? Because your calculator doesn't know what x is. So this is how I know. I'm like, oh yeah, I gotta use inverse because I can't just type sine x into my calculator. So here's how we do it. And I have no idea why this x is jostled over here, so apologize for that. So we hit second, Then we hit sign. Now notice it did inverse. Now you want to type in your 0.7883. So you're typing in what it equals because you're doing the inverse. So once you hit enter, it said to go ahead and round to the nearest degree. So this 0 will not affect this 2. So this is just going to be 52 degrees, like that. So we're finding this angle. X is our angle. Let's do that again with cosine. So I can't type in cosine x to my calculator. So this is when I know, it kind of tips me off I have to use inverse. So you hit second and you hit cosine, and then I'm going to type 0.6694. Now when I do this, I'll find my angle. This 9 is going to bump that 7 to an 8. So this is going to be 48 degrees. I'm going to have you try C on your own. So go ahead and use your calculator and see if you can find out what C is on your own. You can do that now, you can do that later, it's totally up to you. All right, on this next part, they just want to know what trig function you're going to use, right? So we're going to think about SOHCAHTOA, and the more you write this down, the more you'll remember it, SOHCAHTOA. So let's look at A. What angle is there? The only thing they're giving us is D, right? So let's label what we know. Let's label what we know. Do we know the opposite? We don't, so don't label it. Do we know the hypotenuse? Yes, so let's label it. And then this last guy here must be my adjacent. Now, what trig function uses a hypotenuse and an adjacent? What trig function uses an H and an A? And that's cosine, right there, right? Adjacent, hypotenuse. We're given the adjacent and the hypotenuse. So your answer here is, if you were to work this out, you would use cosine. Let's look at B. Here's our angle D. Let's label what we know. Across from D is 5. We're going to label that as our opposite. Across from the 90 is our hypotenuse, but nothing's there, so I'm not going to label it. And then last is going to be 2, which is our adjacent. What trig function uses adjacent and an opposite? An O and an A. It's going to be tangent. Tangent uses an O and an A. So if we were going to work this out, we would have used tangent. Let's take care of C. There's our reference angle. Across from it, straight across from it is a 6, so we label that as our opposite. Across from our 90 degrees is 19, so we label our hypotenuse. We don't label the adjacent because we don't know the adjacent, so let's just leave that alone. So what trig function uses a hypotenuse and an opposite? Which one has an O and an H? Sine. So if we were to work this problem out, we would have used sine for it. So I'm going to ask that you try D, E, and F on your own and bring those to class. So let's recap. Go ahead and finish 1 for class. Go ahead and finish 2C for class. Finish 3C for class. And finish 4, D, E, and F for class and bring those in and we'll discuss it. And until next time, see you later.